Okay, now here we are for our first lecture on chapter 1. In this lecture, we'll talk about the very basic word problems. Some of you have been exposed to this sort of problems probably before, but this might be a refresher for you. Okay, so again, we start with a number here. So if we have a number, all we have is what? The digits, right? Because the numbers are basically is a combination of digits. But even if we have different digits, they have different contribution to the number based on their location, right? For an example, this is only ones. This location is only 1, so that's why the contribution of this location is 1, meaning 9 times 1. This location is called tens location, right? Tens position, so the contribution is 5 times 10. So you see, if you go to the more to the left, you will have more weights added because of the same digits repeated, okay? Because you see, you have 1 here, you have 1 here as well, but the one at the right side, the contribution of that one is only 100, but the later one, the contribution is 1000, and that's how every digit in a number basically is like a placeholder, right? And it basically contributes based on the position, okay, even if that's just the same digit, okay? Now, this chapter will be talking about the word problems, where we will try to solve the problem based on some very basic operations like addition, subtraction, multiplication, division, very basic ones, okay? So the first step to solve the problem is we want to identify what operation we need to do, right? We might be doing like addition, subtraction, or multiplication, division, or might be combination of multiple operations, right? So to understand that, we try to sketch the problem, or we try to get some clue from how the problem is defined. We'll read it a couple of times, and from there we'll try to find that, okay? And then once we know what we need to do, maybe we need to do addition, we need to do multiplication, or we need to do subtraction, we'll do that. And then we might have some formula for that. And then once we are done, we make sure that we have the units right, because in some cases we might have units like 5 inch, 20 feet, those sort of things, because if you just write 20, nobody knows this is a feet, or this is a meter, or there's a kilometer, right? So we always want to write the unit with the number, if we have any, okay? And then we check the answer, okay? And sometimes we use some common sense to guess, or just to make sure that the answer makes sense or not. Now let's start with the addition problem first. Now, how do I know whether the problem is an addition problem? Again, this is a very basic problem, and I'm sure that most of you have seen it before, so it might be a refresher for you. So in most of the addition problem, you will find some sort of keywords. This is not guaranteed, but most of the cases you might see these, that you might see the word sum in addition, or plus, increase, more than, and these sort of things. So some examples are like these: the sum of these numbers, these, you add and get the sum. Or in addition to these, meaning a quantity of 7 in addition to the existing 3, that's an addition, because there is an in addition to, okay? So we try to make those keywords italic so you can see the keywords in the sentence. It might be plus, sometimes we write, most students know this plus this, okay? We sometimes use the word increase, and increase of these to the students of these brought to these. Okay, so that's also a plus, meaning addition. If there were 6 before and 4 more than these, now we have 10. Okay, you see there is also keyword which is more than, right? Because whatever we have is more than these now, so that's an addition. And sometimes we use and these equal to these, right? So that's an addition problem also. Now, just using these ideas, let's look at a real life problem that we can solve using the addition problem. Now for an example, we have a question here. What length of the sash required to frame a window that is 34 inch by 70 inch? Now let's say this is a window, okay? And we also have drawn the window. So if you see, there are 2 different dimensions, right? One dimension is 70 and other dimension is 34. And we are looking for the total, right? We're looking for the total because what we need is we need to find the total length, the stash required to make the frame like this. Okay? And if you also look at the problem, you see that the number, meaning all the numbers are given with what? Inch. Right? 70 inch, 34 inch. Right? So to find the total, what do? We just add all the dimensions, right? Meaning all the sides. There are 4 sides, meaning 2 dimension, 4 side. We add all the sides. Oops. We first know that this is an addition, right? So we add all the sides, but also look at the last line. It said include 1 foot extra for the waist. But be careful, 1 foot and 12 inch, they're in different units, right? Because all the dimension sides are given at inch, right? But the extra is given as is foot. So we convert all the unit into inch or into feet. We did it everything in inch. So what we did is we added all the 4 sides, right? And then we also added 1 foot as inch, meaning which is 12 inch. And then that's the total we have, 220 inch. And that we need a 220 inch long sash to basically make this frame, right? It's a very easy problem. Now let's look at another problem. We're not going to solve it, so I'll let you read this one and see how we solve it, okay? Read the question and see whether you can solve it, or otherwise we'll solve it together. Okay, so this is probably a very easy problem, right? So during a snowstorm, we need a snowplow operator clear the road with the lengths of 5 miles, 2 miles, 3 miles, and 8 miles. So how many miles we have, right? So we just add the total, right? How many miles? It's just 18 miles, right? We just add 5 plus 2 plus 3 plus 8. That's 18 miles. How about this one? On a given weekend, a technician worked 10 hours on Saturday, 4 hours on Sunday. Excuse me. How many hours did he work during the weekend? Obviously just adding, right? It's 14 hours. A flooring contractor placed 50 red tiles, 25 blue tiles, 100 white tiles, and 200 black tiles. How many total tiles? Just add them, right? What is the total? 375, right? Okay, now let's look at a couple of subtraction problems. Now in the subtraction, again, just like the addition, we'll have some keywords. But before we start the subtraction, let me recall that when you do a subtraction, there are 2 numbers, right? Of course. Now the number you have at the top or at the beginning, that is called minuend. Now let's say you are subtracting 25 minus 5. That means the number you have at the top is called minuend. We probably don't use the name too much, but sometimes we need the name because that's how a lot of things are written in the literature. And the answer you will have is called difference. Okay? So number you have at the top or number that comes first when you write in one line, that is called minuend, and the next number is called subtrahend. Okay? And the answer is called difference. Now, we have some keyword, just like the addition, and using this keyword, a lot of times we try to identify whether this is a subtraction problem or not, right? So the keywords can be difference, fewer, less than, reduce, decrease, minus, but again, this is not guaranteed. You might have some additional keywords. These are some very elementary ones. Now the difference means, again, the gap between 2 numbers, right? The amount between 2 numbers. For an example, the difference between 12 and 5 is 7. That's an example. Fewer, another example. With 5 fewer boards in a box originally contained 12, that means 12 minus 5, which is 7, right? Another example, if you have 12 and now you have 7 less, that's a subtraction problem, right? 12 minus 7, you get 5. Reduce, another, this is a process of making it smaller. That means thus the class began with 20, now you get reduced to these. how much will be the total? So this minus is 20 minus something, you'll get the total what we have right now. Decrease after a sale, a supply of 40 tires decreased by 10. That means 40 minus 10, right? Which is total, which is right now 30. So you have 30 tires left. Minus another, another example for subtraction. That means something has been removed, something has been deducted, right? A case once had 24 cans, now has 4 less, 4 reduced, 4 minus. It's 20 minus 4. I'm saying 24 minus 20, that is the 4, right? Now let's look at an example here, which is a word problem. The electricity used by a small business in Memphis was 2,000 kilowatts in July. The business has to pay the power company a base rate plus a surcharge for the power used in excess of the base rate, which is 1,500 kilowatt. Now, how many kilowatts were used in excess of 1,500? Again, subtraction, right? Total is 2,000, and you used what? 1,500 more than what? The base rate was what? 1,500. So you used more. What? How much more? 500, right? It's 2,000 minus 1,500, right? So you get 500. Another problem here. An electric meter read 2,500 kilowatt hour at the end of June. Okay. At the end of July, the meter read 3,300 kilowatt hour. How many kilowatts hour of electricity were used during the month of July? Again, at the end of the June you have something, at the end of the July you have something. If you subtract, that will be 800, right? 3,300 minus 2,500, so that will be 800 kilowatt hour, right? Next problem, an appliance warehouse delivered 40 stoves during 1 week. If there were 150 stoves in the stock at the beginning of the week, how many were in the stock at the end? Again, subtraction, right? Because they started with 150, and in the middle, during the week, they supplied 40, and they are left with 140 minus 150 minus 40, which is 110, right? Let's look at a couple of multiplication keywords. Again, when you multiply, you have multiple numbers, and all the numbers are called factors, and what you get is called product, right? Let's say you said 5 times 3 times 3. So all these 5, 3, and 3 are called factors. And what you get as an answer is called product. Some keywords for multiplication. Some of the keywords apply, I'm saying that, they appears in multiple places. So the keywords we have for multiplication is product, art, times, by, rate, par. These are some, clue. Let's say the product of these and these is, 3 and 8 is 18. The product is directly coming from the multiplication. Sometimes we use at. 75 nails at 2 cents each cost 150 cents. But again, remember, a lot of things in the multiplication are also used in division, but multiplication always require you to find the total, right? Or if you need total, you probably look for multiplication. But if you have total, but if you are looking for 1 or 2 or something, then you probably are looking for division, right? Okay. This is like times. If you jog 2 miles 3 times a day, that's like what? You'll just have a multiplication, because and multiplication is also like a repetitive addition, right? So that's why you also try to show you here that 2 miles 3 times, that means you are just adding 2 3 times. Yeah, that's, if you add, that's also work 3 times. Flooring tiles are 12 by 12 inch. How much is the total area? That's like a multiplication problem, okay? You have 2 dimensions, and you are trying to find the total area of the tile of a floor. It's 12 times 12, it will give you again 144 inch square. Rate, another example of for multiplication. If a worker earns $8 an hour for 8 hours, he earns in total what? 8 times 8, $64. Par, another example for multiplication. It indicates how often an event is repeated. right? How frequently? If a car travels 60 miles per hour for 2 hours, it will travel what? 60 hours, 60 miles per hour times 2, right? 120 miles, right? So remember, the power is also used in division, but use multiplication. But the only difference is, in case of multiplication, individuals are given and you will be finding the total, right? But in case of division, individual will be, you have to find the individual, but you are given probably the total, right? So that's like the backward process. But this keyword is also used in multiplication, in division as well. Okay. Now, this is a word problem for multiplication. So let's see. Let's read it. The instructions for a medication are 5 milligram per pound of body weight. What is the dosage for 40-pound dog? That's like a multiplication, right? So you need, you are given the required medication for 1 pound, which is 5 milligram, and you have to find it for 40 pound. So just from the keyword par, you know that this is a multiplication problem because you are given individual weight, individual measurement of the medication, but you have to find the total medication required. So you do the math, 5 times 40, which makes it 200, and the unit is milligram, so the answer is 200 milligram. Right? Again, another problem. So if we have a dog for if we have a 10-pound dog, it will be what? 5 times 10, right? 50 pound. Some keywords for division. Before that we have the keyword, let's look at how we have what we have in the division. When we divide, let's say we are dividing 25 by 5. Let's say we are dividing 20 divided by 4, okay? Now 20 is called dividend. The 4 will be called divisor. And whatever you will get, okay, maybe I'll add a little bit here. So let's say I have 21 here. 5 times 4 is 21. Now this 5 is called quotient, and whatever you are left with, that will be called remainder. It's important to know the names a lot of time, because literature, we always go by the names, right? So in case of division, these are the terms we have, and these are the keywords for the division. Quotient divided into par, right? Quotient is exactly what you get when you divide. That's the answer of the division, right? So the result of having performed the division is the quotient. So that means 12 divided by 2, and the quotient is 6. Quotient of 12 divided by 2. Divided into, again, that's an indication that you are dividing something, which is a division. So if the 100 divided into 5 equal amounts, each amount will be what? 100 by 5. 20, right? So that's again a division. And the par, again, remember, the par was also in multiplication, but look at the difference. The cost of 5 boxes are given, which is $10. And you have to find the cost of 1 box. That's the difference between the division and multiplication, right? In the division problem, you will be given the total, and you have to find the individual, because you are given the price for the 5 boxes, which is the total box, but you are looking for only price of the 1 box, meaning the cost of 1 box. And you do the division, 10 by 5, you will get $2 per box, and that's the price. Okay? Now let's look at a problem here. Okay? This is an interesting problem. How many rungs are needed for a ladder that is 70 inch long if the rungs are 10 inch apart? looks like a division problem, right? Because you have a 70-inch long ladder, right? And you will be needing 10-inch a rung 10 inch apart from each other, right? So somebody can find, oh, let's see, 70 inch by 10 inch, that's what, 7, right? But let me tell you this. Even if, you know, this looks a division problem, which is division problem, but there is a little trick here. Let me draw it. Now let's say this is a 70-inch rung, and you are trying to draw 7 rung here, okay? Now what happens is, if you draw the 7 rung, 10 inch, 10 inch, 10 inch apart, right? 30, 40, 50, 60, and 70. Now, think about this ladder. Let's say this is a 70-inch long ladder, and between every single pair of consecutive pair of rungs, you have 10-inch gap, right? And these are 7 rungs you have. Do you really need, you need 7 rungs? You actually do not need this rung, right? Do you? So actually the answer is 6. Even if this is a, oh, why 5? Because you don't have anything here, because I just have drawn 7, right? Oh, you don't have anything in the top. If you have 7, okay? If you have 7, you know, try to draw it, because it's like 10 here, 10 here, 10 here, so it's like 10, 20, 30, 40, 50, 60, 70. And I have drawn 7 rungs. 1, 2, 3, 4, 5, 6, 7. Now look at this, the last one you don't need it, right? Have you ever seen this rung with the, you know, this sort of rung? So that means even if this is a division problem, we sometimes use a little bit of common sense, and that makes it 6. Okay? So be careful about this sort of problems. You know, this, like, you know, it's a division problem, but it's very bit. Somebody gave me a problem when I was a child. He said, okay, we have 20 birds sitting on a tree. If you shoot 1, how many birds are left? We have 20 birds sitting on a tree, okay? And if you shoot 1 bird, how many birds are left? They will all fly. So you have just zero birds left. It's not 19, right? I'm saying, you know, it doesn't. It looks like a subtraction problem, but that's not. Now, you know, we just tried to tell the same thing. Yeah, you don't need the last rung. Okay. Now, sometimes some of the problems are like combination problem. It's not only about an addition or subtraction. You might need multiple operation, right? You might need addition, subtraction, multiplication, division combined, right? Let's look at one such problem here. Let's say we have a wall which is 330 square feet in area and has a window that is 10 square feet and has a door that is 20 square feet on the wall, okay? Now, how many gallons of paint we require to cover the wall if the gallon covers 100 square feet? Now, let's first check the wall. Now, we have a wall here. Let's see. Let's say we have the wall here, but there is a door and there is a window, let's see. Okay? Now, when you actually paint, you are not going to paint in the window and the door, right? So that means you basically will subtract their area, right? The total area is what? 330. So you subtract 20 for the door and 10 for the window. So you are basically, you will be left with 300 square feet, which is actually what you need to paint. So this part of the problem is a subtraction problem, right? But you are not done yet, because you actually need to find how many gallons of paint you will need when 1 gallon can cover 100 square feet, right? What is this problem about? Is it a multiplication, division, what? So look at the problem. This is, you are given the total, right? You are given 300 square feet and you are looking for how many you need in total. So this is a division problem. So what you do is 300 divided by 100. So you will know that this is like 3 gallon of paint you will need actually to cover the whole wall. Now look at this problem. This is a combination problem because the first part of the problem you did a subtraction. In the second part you did a division, right? A lot of problems in the real life will have these, right? So you will not have exactly one single operation. Instead, you will have multiple operations, right? Okay, so this was the first chapter. So this was probably the easiest ever we'll have. Over the time, we'll get into more. And as you have seen today, we had the pretest, right? This is exactly what we'll be learning, and even more than this, because we did not have any trig here. There will be a lot of algebra and trig also at the end of the class. So you can feel that how we are going to learn and what exactly we'll be learning at the end of these, because all these questions will be extremely easy to you after we are done. Now, since we are done with this chapter, we'll go to the assessment in the pause and click on the quizzes. Do you see there is a quiz section under the assessment? If you click the quiz, you will see all the quizzes for this class, including the test and sample test. You cannot stop the test because those have dates. But for each chapter, we have one or more homework. Okay? Now, since we are done with the chapter 1, and there is only one homework for chapter 1, you can just know by the name, the first one. Chapter 1, word problem homework. Do you see it? The first one. Okay? Let's go to the quiz section and let's finish the homework. And again, all the homeworks, you have 25%, so that's your grade, and you can do the homework again and again. Okay? Every single time you submit, you see the grade, and pause records the highest grade. Meaning, if you try it today, you get 40%. Try it tomorrow, you get 100% new grade. Now, once you get 100%, if you try it again later and you get 50% in future, you still grade is 100% because we recorded your highest grade.
So you
okay?
can't save your work.
You save it, submit it, and you will get the grade. And every single time when you submit, you can always see what you have submitted. You can always go back to your previous submissions. You cannot change the grade though, because once the grade is done, you cannot change the grade, but you can start over. You can do the same problem. And remember, every single time you start, you'll pretty much see the similar question, but with different numbers. So that means it's like a practice, okay? If you start again and again, you'll see same question, but out not the same, out say similar questions, because it will be the same number, it will be different numbers, okay? Now let's go to the quiz section. Of course, after each and every chapter we'll do this. We'll go to the quiz section and we'll try as much as we can to finish this, Sometimes we will not be able to finish because we'll have multiple homeworks, we'll have long chapters, right? These are the easiest one and the smallest one, so So what we do is we'll finish all the homeworks before we come back for the next time, because we have the whole week. Do it again and again, get 100%. Because when you submit, you actually will see what questions you missed, so you can try those, next time, and you understand why you missed, right? Now let's go to the quiz section and let's do the chapter 1 word problem quiz or homework.